Hello, Math Humans. We're going to do 6.1a today. We're finally going to talk about slope fields. Our objectives are that we're going to generate a slope field. So let's go back and talk about differential equations first. So a differential equation might look like dy dx, and it equals some equation, potentially in terms of x and y. We're going to cross multiply and get dy is equal to our equation times, dx, and then I integrate both sides. And the goal is to be able to find a solution for y. And we find either a general solution or we find a particular solution. So a general solution would be y is equal to whatever our equation is at that point, plus c, and then remember the particular solution you actually solve for c. The general solutions can show up on a slope field, and so they create a family of curves. And if you'll notice by the equation, they all differ by plus c. So depending on the value of x and y, the c is going to have a different value. And those are different, so our family of curves differs by a vertical translation. Alrighty, so basically what happens, a slope field is kind of like a scatter plot. It's a way of visualizing the many different slopes of a function. All right, so there's kind of what it represents. So let's just kind of walk through an example. So if I were given dy over dx is equal to a negative x over y. Remember that dy dx is actually the slope of the function at any point along the curve. And so if I wanted to generate a slope field, I would draw a table, and it would have x and y, and then it would have, the last one would be dy dx. So let's say I chose the value 0 and 1, okay? And I'm going to put my slope field right here so we can see them side by side. And I'm looking at the point, this is 1, 2, and 3, and I'll do 1, 2, and 3. Typically, when you have to generate a slope field, they give you the values where they want you to create it because there are an infinite number of values. And so typically they will tell you what grid they want you to use to fill in the slope field. Well, if I substitute these into my dy dx, I get that the dy dx is equal to 0. If dy dx is 0, that means that it's a horizontal line. So at the point 0, 1, I have a little segment, okay? So the next point that I'm going to choose, I'm going to do 1, 1, okay? If I substitute these values into my formula for dy dx, I get a negative 1. So I would go up to 1, 1, and I would draw a short line segment that looks like y is equal to a negative 1x, okay? My slope is a negative 1. Then I'm going to go to 1 and 0, right? And I'm picking values of x and y. I'm picking them from the grid. So 1, 0 is going to be right here. Well, if y is 0, that means that the slope is undefined, and an undefined slope is a vertical line, okay? And then let's say I chose the point negative 1, and y is a negative 1, so I'm looking at this point right here. When I substitute it into my equation, I get that the value is also negative, so I would put that there. And then if I chose 2, 2, then my slope would be, oops, I skipped a point. Let's choose 1, negative 1. Okay, so let's come over here, and my slope would be a positive 1. So right here at 1, negative 1, I would have a positive slope, okay? And you can keep managing this information for all of your points. It would be overwhelming to do 1,000,000. But if I did a few more, and I'm not necessarily going to put them on my graph, and then up here at 2, and then I would have one over here, and so you can see that it starts to show a pattern for the graph. And in this particular case, it almost looks like our graph represents a circle. So when you're going to generate a slope field, you have to show the table. So oftentimes this is an FRQ type problem. You must show the table. Number 2, your slopes are going to be represented by the short little lines. But your short little lines need to accurately reflect the slope. So accurately, I'm not sure how to spell that, accurately reflect our slope. So if you'll notice from the example that we did, if the slope is vertical, so if slope is vertical, undefined, on your chart, then you need to have a little vertical segment. If the slope is horizontal, then you need to have a definitive horizontal line, and it's just going to be these little segments. If your slope is 2 and you had a slope that was 1, when they're looking at your graph, they have to see a difference between the two types of slopes. So maybe this is the slope of 1, so maybe this is the slope of 2. They're not actually going to test to see if your slope is 100% accurate, but they do need to see that there's a difference between the two different types of slopes. And then the third thing that you need to do is you're typically going to be given your x and y values. Because when the examples come up that I'm about to show you, given your x and y values, there are an infinite number of points that you could use to generate your slope field, and so they typically will give you maybe 6 to 9 different points that they want you to generate. All right. The next thing that I'm going to show you is kind of what we're talking about with our slope fields. Sometimes they'll give you a slope field, that's cool looking, and ask you to generate a curve. And so it looks like, kind of if you follow these dots, that it looks like a parabola. And if you'll notice, it creates, this is that family that I was talking about, and these are all translated vertically. So they're vertical translations, and that is the plus C that we see when we find a general solution. Okay. Another one, just another example, you can see kind of a pattern down here in our curve, and notice that they've sketched it. So they just have a curve and then they sketched it. And again, it could be separated by a family of vertical translations. So it's kind of cool. Okay. All right. The last thing that we're going to do is we're going to actually take a slope field and an equation, and we're going to generate the values, and then we're going to look for those on our curve. So again, this has a bazillion points on it, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, and then I have all of the points in between. So we never really want to generate that many values. We're usually only going to generate maybe 6. But in this example, so this is technically our first example, I actually want to go through and generate the table. So my dy dx is going to be y minus x, and I'm just going to choose a couple of points, and then we're going to compare the slopes that we find with the slopes on the slope field. So I'm going to create my table. I'll do it down here. So I have x, y, and then I have dy over dx. Okay. Alrighty. So if I choose the point 1, 1, so x is 1, y is 1, my slope is 0. So if I go onto my graph, at the point 1, 1, notice that the slope is 0, okay? So that notice how it's reflected on the graph. So then if I did the next one, let's say I chose 2 and 1, the slope would be a -1. So if I go to the point 1, 2, and then 1, notice that my slope is a -1. It's kind of hard to draw a bunch of circles, but you kind of get the general idea. Okay, so let's go out and choose a point that's a little bit further away. So 1, 2, 3, 4. Let's say we chose the point 5 and 0. So the slope is going to be 0 minus 5. So the slope is going to be a -5. So at 1, 2, 3, 4, 5, okay, this is really hard to tell. It's very steep, but you can tell that it's a negative, okay? So that would be what's required when we do the math. Occasionally what happens, the way these problems present themselves, is they will give you a differential equation, and they will either tell you to generate the slope field, or they will give you a choice of several slope fields and ask you which one matches the equation. Alrighty, that is it for today. I will see you soon.